Hi, y'all. My name is Wes Tierney, and if you don't know me, I am one of the 15 Better programs, fairly, I don't know, infrequent or semi-regular STEM or science lecturers. And for those who do know me, hi, welcome back. I hope all of every group will join me for this next lecture, which will be dealing with CRISPR and a lot of the treatments that are being developed along with CRISPR. But for the moment, if you don't know what CRISPR is, let me give you a bit of an example. So come along with me and imagine you're a little younger than 12. And after a stressful day, after maybe like a math test, if you can remember being 12, you start to feel a little bit of pain almost in your entire body. Your arms, your chest, your back, your legs. This pain only worsens throughout the day, getting to the point where most would call it extreme, in which case you are taken to the hospital. After some blood tests, specifically one looking at, or just general tests, but specifically one looking at your blood, the doctors find that some of your blood cells are the normal rounded shape. They have a little divot in them. And some of them are misshapen. They look closer to a crescent moon or what you might call a sickle. In which case, after some other confirmatory tests, you are told that you have sickle cell disease, or SCD. There are treatments. You will have to get them the rest of your life. And unfortunately, your lifespan is about 20 years shorter than your peers. This is the reality for about 100,000 Americans, but hopefully there's some new treatments being looked at right now and have been tested on some folks with SCD. So using a new technology known as CRISPR, some of the treatment takes the patient's blood cells and is able to make them into the mature or the non-sickle cell version of those blood cells and then being put back into the patient. CRISPR, in this case, is a gene editing technology, meaning that it can alter genomes within organisms. Clinically, this holds promise to alter disease such as sickle cell disease. However, as I think a lot of other people know it as well, it is a controversial clinical application. In the laboratory, when we're doing basic science, not working on humans and not really even thinking about how to use this within human beings, fairly uncontroversial, just kind of a new fancy tool to be used. But as it's applied to humans, it's become a controversial tool. The one that most people will know is the work of the Chinese biophysicist He Jian Kui, which was used to make the CRISPR babies, Lulu and Nana, which led to eventually his imprisonment. He's out of prison now, but he has been notorious or controversial ever since then. And we'll be going over a little bit of that. But come join me for over about 2 weeks. It'll be a two-part lecture. So we'll discuss CRISPR as a technology, as a clinical tool, and what it had already led to and what it could possibly lead to in the future with both its promises and its potential controversies. I hope you all join me. Excited to be able to teach everyone about a new tool that we actually took, as many of our tools are in the biological sciences, from other organisms, in this case, bacteria, which is no stranger to us taking its tools a lot to be used in the lab. But I hope you join me, and I hope we have a good time over the 2 weeks. Discuss CRISPR in general, where it comes from, what it does, what it can do, and then likely the next week we'll be dealing with mostly the treatments, reviewing what we did learn the week before about what CRISPR does and how it's applied and how we're going to try not to apply it in the most controversial senses and where that line is. But either way, it should be fun. I always enjoy doing these lectures for all of you. So I hope you can join me, and I will see you then. Goodbye.